What's up, Algebra 1A? All right, so today we're going to talk about stem and leaf plots. You've probably seen them before. If not, they're real simple and real simple to use. Really what it is, it's just a way to organize data in a more concise way. So when we look at a stem and leaf plot, what we need to understand is that when we have this setup on this side, those are called the stems, and on this side are the leaves. And oftentimes when you're looking at one of these, they will have a little key down on the side that'll say like this means 21. You don't really need that because basically what it boils down to is that the leaves can only have a single digit. So when I'm seeing something like this, what this is really telling me is that my data is 20, 22, 23, 27, then going down here 30, 35, so forth and so on until we get through all of this: 37, 39, 41, 41, 43, 44, and 59. Now, the nice thing about it is when you see a stem and leaf plot, your data is already organized from least to greatest. So when you're finding your measures of central tendency, it's very simple to do. So if we had this, I'm going to go ahead and make some room here. So if we had this and we wanted to find our measures of central tendency, we can do that extremely easily. So if I want to do my mean, I can simply go ahead and total all these values up. So we have 20 plus 22 plus 23 plus 27 plus 30 plus 35. I don't have my glasses on, so hopefully I'm not screwing this up. 39 plus 41 plus 41 plus 43 plus 44 plus 59. So that gives me a total of 461. And then when you go back to find how many pieces, you only have to add these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So if I divide that by 13, I have a mean of 35.4615. We'll call it 35.5. 35.5. Now, when it comes to the median, since our data is already organized, we can simply do this. I have 13 pieces of data. That means the middle will be the seventh piece from either end. We'll have 6 on either side. So I can count up 1, 2, 3, 4, 5, 6. And then I have 1, 2, 3, 4, 5, 6. That makes my median 37. Whoa, it's an ugly D. Then mode is just as easy. I'm looking at this and I say, okay, I'm just going to look for where leaves repeat. I only have one set of leaves that repeat, so that means that my mode is simply 41. And then, of course, last thing is range, which is taking the largest minus the smallest. If I'm going to take 59 minus 20, I know that my range is going to be 39. So it's not different work, it's just different ways to display the data. It's that simple. We could also take this further and we could find our quartile 1 and quartile 3 and go ahead and create our box and whisker plot. If I know that I have 1, 2, 3, 4, 5, 6 in that lower half, I would have 1, 2, 3, 1, 2, 3. So I know it lies between 23 and 27, which of course would be 25. So my quartile 1 is 25. Do the same thing for quartile 3 with the upper half. 1, 2, 3, 1, 2, 3. So that means that my quartile 3 is right there at 42. So now I have all my measures of central tendency. I have enough information that I now can make my box and whisker plot, which we have already done. So we should be okay to move forward after getting that information. There's one other thing they like to talk about, and they like to talk about outliers. Now, I have a feeling you've heard of outliers before. That's data that lies outside of the central tendency stuff. Now, the problem here is I get a lot of students who think the very first and very last number have to be outliers. That's not always correct. In fact, it may not have any outliers. So when I look at the initial part of my data, I have 20, 22, 23. There's not an outlier here at the bottom level. The reason there's not an outlier is 20 to 22, 23, they're not that spread out. There's no piece of data that really stands out from the rest. Now, when I get down to the bottom, or actually the highest number, then I start looking and realizing that my data is 41, 41, 43, 44. Then all of a sudden it makes a fairly significant jump to 59. So when it comes to that guy, I would say, yeah, he's kind of sticking out from all the data, especially if I had a boxing whisker plot. That upper whisker would be like really long compared to the rest of the data. So the outlier here would be 59. And outliers are a lot like your mode. There could be more than one. It could be several at the bottom, or one at the bottom, one at the top, or there could be none. Okay, it's kind of a judgment call, but make sure it looks like that. Those pieces of data are really far apart from the rest of it. So hopefully, I think that example will be enough. The only other thing I want to mention is that if you're looking at data that would look like this, oops, done made a mistake here. We'll just put that up there. Keep in mind that it's still the same process. The difference is now your leaves are your single digit. So the first digit that you would have, or piece of data, would be 204, then 205, then 209. Then when you drop down to the next, that represents 211, 213, 218, and then 225 and 229. So your leaves always are a single digit. These are the numbers out front necessary to create those digits. So take this and just put the single digit onto the end, and that would be your pieces of data. So what I'm going to do at this time is I'm going to put a stem and leaf plot up. You're going to pause the video. I would like you to find those, all the measures of central tendency: mean, median, mode, range, and then quartile 1 and quartile 3. So we have all the central tendency and the ability to make a box and whisker plot off of it. So I'm just going to go ahead and make one up here. So we'll start with 4. We'll have 48, 9, so we're going to find the mean, median, mode, range, quartile 1, and quartile 3. I'd also like you, when you're done that, tell me if you see, hopefully you guys can see this on the video, tell me if you can find any outliers. So go ahead, pause the video, go ahead and find all that information, then come back to the video, check your answers, make sure you're good to go. Welcome back. Go ahead and check your answers, see if they make sense. I'll talk about them briefly. Mean, of course, we just add them all up, divide by the total number. There was 13 again. So that gives me a mean of 57.23. The median, since there's 13, 1, 2, 3, 4, 5, 6. There's your seventh. 1, 2, 3, 4, 5, 6. That splits the data right in half. 56 is your median. Mode. Now, 51 repeats. There's two 51s, but then there's three 62s. So 62 is a mode, 51 is not. Remember, it's the one that repeats the most. Range, 78 is your highest, 48 is your lowest. Subtract those out, you get 30. Quartile 1, again, we're going to split that bottom half. This was my median. So my bottom half is 1, 2, 3, 4, 5, 6 numbers. So 1, 2, 3, split, 1, 2, 3. That would be 50 and a half, right between 50 and 51. Quartile 3, we're going to split the upper half. So 1, 2, 3, right there, 1, 2, 3. And of course, if it's lying between 62 and 62, it's 62. So that's quartile 3. And then outliers, 48 is not, because there's a 49, there's a 50, it's right in there with the data. However, going from 62 to 78, that's a significant jump compared to the rest of the data. So I would consider 78 an outlier. Hopefully that made sense. Hopefully you're good with that. You're going to go ahead and do the practice test for Objective 5 tomorrow. And then we're going to have a Google Meet Thursday. Make sure everybody's good with everything. And then you're going to go ahead and take your practice test. Check. Hope you all guys are doing well, safe, happy. Wash your hands. Help around the house. Talk to you later.